Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have just introduced the word of polymer and we have seen the monomer as a tiny substance or atom that combine together to form large structure of polymer. And we have seen their classification as well. If you have missed that video, you can find it in the I button over here. So now in this video, we are going to focus on functionality of the polymer and we will see how this functionality affects the structure of polymer. Now let me just take a pen so that I can explain you this concept of functionality in much more detail. Well, the functionality of the monomer can be defined as the number of site present in the monomer, right? So basically functionality is nothing but number of site present in the monomer for bonding to another monomer under given condition of polymerization reaction. To explain this, let me just take one example of ethene molecule. We have ethane as two carbon which are connected with the double bond like this, and both the carbon has two hydrogen atom, right? Like this, these two hydrogen are been attached to this carbon and two hydrogen is being attached to this carbon. Now let me just tell you one thing. This carbon hydrogen bond, particularly this carbon hydrogen bonds, are very strong. So we cannot easily break this carbon hydrogen bond. Instead, what we do is we break this carbon carbon bond which is relatively weak. So what if I break this particular bond like this? Let me just show you this particular bond I have broken out, right? So due to this carbon is now having one free radical or one electron is free now. But similarly, this also carbon also has been one free radical. That means this carbon can linked with another molecule or another monomer in this way, and this particular carbon can also react with one more hydrogen or one more monomer like this. So we can say that this particular element of ethene is basically bifunctional monomer, right? It has two active side, or it is basically there are two bonds that monomeric unit can form, right? This monomer can form two more bonds, one in this direction and one more in this direction. So this can be defined as the functionality, and the symbol for this is F. So this particular substance has functionality equal to 2, right? So I hope by now this concept of functionality is being clear to you. Let me just show you what we mean by bifunctional and monofunctional monomer. That will clear all the picture related to the functionality, right? So monofunctional monomer are the monomer having only single bonding site, right? I want your focus on the screen and particularly to this word, that monofunctional monomer are the monomer having single bonding site, right? So basically they can join or they can linked with one more monomer only. To explain you this, let me just take one example like this. We have ethanol, that is what, let me just draw you for this carbon atom has a 3 hydrogen, likewise this, and it is also attached to this hydroxyl group here, right? If I react this ethanol with acetic acid, which also has a carbon attached to the 3 hydrogen like this, and one carboxylic group, that is COOH like this, right? So when these two, ethanol and acetic acid, react to each other, both has one functional group. This one has the OH group and this one has the COOH group, right? So when they will react, they will form one monomer like this. This carbon will have 3 hydrogen, as this hydrogen bond is relatively strong, so we cannot break this hydrogen bond, and this will connect to the COO bond, and again it will be connected with this carbon, and this carbon will have its 3 hydrogen like this, okay, and we will have one H2O molecule as well. So this can be considered as the monofunctional monomer, because now they do not have any active site. They were having only single active site so that they can bond with one more molecule like this. But when they are reacted, here on the screen you can see that when this complete reaction between these two monomers is finished, they cannot form a chain reaction, right? So this chain is terminated, this chain is stopped now. So basically this kind of a structure or this kind of a substance called as the monofunctional monomer, right? You can see here in this image as well, this particular structure I have drawn here, that CH3 C double bond CH3. Now this ether is basically known as the monofunctional monomer, as it has only one active site, right? So now let me just move to the higher number with the functionality F is equal to 2, and that is nothing but bifunctional molecules, right? We have already explained you that bifunctional monomer has two bonding sites, right? Let me just focus here. Basically bifunctional monomer has two bonding sites, so that means they can link to another molecule or to another monomer under suitable condition of polymerization, right? So let me just take one example so that it will clear everything to you. That ethane molecule that we have discussed in earlier stage, that ethane molecule, this carbon double bond carbon is being attached with two hydrogen molecule like this, and one hydrogen is here. This hydrogen is being attached to this, and this hydrogen is being attached to this. Now again this hydrogen carbon bond cannot be break because it is very strong. So instead what we do is we break this carbon carbon bond, right? Like this I have broken out this. So this carbon can be linked with one more molecule, and this carbon can also be linked with one more molecule like this. So what will be happen is that there will be chain reaction will happen, that this hydrogen, this hydrogen, this hydrogen is here, this hydrogen is here. Now this particular carbon can react with one more hydrogen in this way and in this way as well, right? So let me just draw one more monomer of ethene, double bond here. One hydrogen is being attached to this, one hydrogen is here, one hydrogen is here. And if I break this thing, so what will happen is, just let me just remove this thing. If I have break this thing, one more monomer can also react with this thing, right? So here one more ethene group can connect it. So like this chain of reaction will continue, right? So we can say that this ethene is basically bifunctional monomer, right? Let me just quickly take one more example of this bifunctional group so that it will clear a complete picture about this functionality, right? Now let me just rub this thing quickly, and we will have one example of a substance called as the let me just quickly rub this thing, ethylene glycol, right? Let me just take example of, so ethylene glycol basically has a two carbon like this. Here is one more carbon, and both the carbon are attached to the hydrogens like this. Here you can see this hydrogen, and this particular carbon is attached to this hydroxyl group, and this particular carbon is also attached to this hydroxyl group. So now this particular monomer of this ethylene glycol can react in two ways. One, it can be reacted in this direction, and it can also react in this direction as well. So we can say that this ethylene glycol has the functionality of two, because it can be reacted with this one group, and it also can be reacted with this one group as well, right? So this is the one more example of bifunctional monomer. Now let me just show you different bifunctional monomer. Here in this image you can see that I have explained you this thing, right? Ethylene, example of ethene as the bifunctional, and here is, you can see on the screen, example of malonic acid, right? So both the compound can be considered as the bifunctional monomers. Now let me move to the higher number and introduce you with the trifunctional monomer. Basically trifunctional monomer has the functionality F is equal to 3. You can see on the screen that they are the monomer with functionality equal to 3. So basically they can form 3 bond with another molecules. and they are generally of a three-dimensional structure, right? Three-dimensional network can be formed with this trifunctional monomers. The example of this monomer is phenol and glycerol. So basically, let me just draw you this glycerol. It has three carbon atoms like this, and here this carbon is being attached with two hydrogen like this and one hydroxyl group, OH group here. This intermediate carbon is attached to this hydrogen and OH group here. This last carbon is attached to this hydrogen in this way, and one more OH group is being attached to this. Now you can see on the screen this particular element can react in three directions. This OH functional group can be reacted with one more monomer. Meanwhile, this OH group can also be reacted with one more monomer, and lastly this OH molecules can also be reacted with one more monomer. So likewise, we have three functional monomer, and the example for this is the glycerol, right? So in exam, these particular examples are very important. This question can be asked for 3 to 5 marks in your GTU examination as well. Right. So let me just show you this trifunctional monomer with the example of phenol. This phenol can be reacted in three direction in the ortho, meta and para direction. I mean this three direction is being available for the bonding of these another monomers, right? So we can consider phenol as the trifunctional monomer. I hope this trifunctional monomer is clear to everyone. Now let me move to the higher number with the tetrafunctional monomer. Basically tetrafunctional monomer are the monomer having functionality of 4, right? That means they can be connected with 4 functional group, right? You can see on the screen this tetrafunctional monomer can be reacted with 4 functional group that can be bond with another monomer. Like here you can see in this particular image that this particular divinyl benzene can be reacted with, if I have cut this bond, then there will be two free radical form, one will be here and another one will be here. So now similarly if I cut out this bond, there will be two free radical form, one here and one more here. So by this mean this free radical can react with one more group and this with another one and this with another one, and by now we have 4 functionality, right? 4 bonds by mean this particular divinyl benzene can react with. But in general, tetra-functional monomer are very rare because they are very complicated and complex, right? So in general terms, up to functionality of 3 is there. So we are mainly focusing on the tri-functional monomers, right? So now, having said that, this was all about the functionality of monomer. This question is very important for the exam point of view. We will see you in the next video. Till then, keep watching, keep learning. Thank you.